In this video I shall discuss vector product of two vectors. When a vector quantity is multiplied by a vector quantity and we get a vector quantity, such a product of vectors is called vector product. For example, cross product of moment arm and force gives us torque. Moment arm is a vector, force is a vector, and torque is also a vector. So the product of two vectors which result in a vector quantity is called vector product or cross product. The cross product of a vector and b vector can be written as a cross b is equal to magnitude of a vector and to magnitude of b vector and to sine of theta, the angle between a and b, and the direction of unit vector n. The cross product of a vector and b vector gives us a third vector, a cross b. A cross b is different vector from a vector and b vector. A cross b is perpendicular to both a and b, or we can say that a cross b is perpendicular to the plane containing both a and b. A cross b is in the direction of unit vector n. The cross product of a and b can also be written as a cross b is equal to a into b sine theta, or a cross b is equal to a sine theta into b. Now we are going to explain the meaning of these two equations. The meaning of this equation is a cross b is equal to magnitude of a vector multiplied by the sine component or perpendicular component of b, which is perpendicular to a. That is, we multiply magnitude of a vector multiplied by the component of b vector, which is perpendicular to a. And the meaning of this equation is we multiply the magnitude of b vector with component of a vector which is perpendicular to b. We get same result from all these three equations. When we are given two vectors in magnitude form, we can use these relations. But if we are given two vectors in component form, like a is equal to xi plus ayj plus azk and b is equal to bxi plus byj plus bzk, then the cross product of these two vectors can be obtained by expanding this determinant. Here we have put I, j and k in the first row and components of first vector in the second row and the components of second vector in third row. To expand this determinant, we ignore the column and the row containing I. We are left with ay, az, by and bz. So we take the determinant of these four elements and multiply the result with the I unit vector. So we get ay, bz minus az, by and to unit vector I. Now we take the determinant of these four elements by ignoring the column and the row containing j. So we get ax bz minus az bx and to unit vector j. Now we take the determinant of these four elements by ignoring the column and the row containing k. So we get x by minus ay bx and to unit vector k. So we get the cross product of a and b like this. Here we can see a minus sign. Where this minus sign comes from? This minus sign comes from power of minus 1. The power of minus 1 is multiplied with each term. For second term, j is in first row and second column. So 1 plus 2 is equal to 3. Minus 1 power 3 is equal to minus 1. And when we multiply minus 1 with this term, minus sign comes here. Similarly, you can check the rest of the terms are positive. In this video, I shall discuss scalar product of two vectors. First, we see how we can get product of two vectors. For example, we have two vectors, a vector and b vector. There are two methods by which we can multiply these two vectors. The first method is when we multiply two vectors, we get a scalar quantity. For example, the product of force and displacement gives us work Work is a scalar quantity. The product of two vectors which result in a scalar quantity is called scalar product or dot product. Generally, dot product is written as A dot B is equal to AB cos theta. The second method of multiplying two vectors is we multiply two vectors and get a vector quantity. For example, the cross product of momentum and force gives us torque. Momentum is a vector quantity, force is a vector, and torque is also a vector quantity. The product of two vectors which result in a vector quantity is called vector product or cross product. Cross product is generally written as A cross B is equal to AB sin theta in the direction of unit vector n. In this video I shall discuss just the scalar product. The vector product or cross product will be covered in a separate video. So now we are going to discuss the scalar product of two vectors. Suppose we have two vectors A and B making an angle theta with each other. The dot product of these two vectors can be written as the magnitude of first vector multiplied by magnitude of second vector multiplied by cos of the angle between the two vectors, that is A dot B is equal to magnitude of A and to magnitude of B and to cos of theta. We can write this equation as A dot B is equal to A into B cos theta, that is we can multiply the magnitude of first vector A with cos component of B vector. This equation gives us the same answer as previous equation. There is no difference between the answers. We can also state that the dot product of two vectors is equal to magnitude of first vector multiplied by the parallel component of a second vector, or the component of second vector which is in the direction of first vector. We can also write the dot product of these two vectors as A dot B is equal to A cos theta into B. That is, we can multiply the magnitude of second vector with cos component of first vector. That is, we can say that A dot B is equal to the magnitude of second vector multiplied by the component of first vector which is in the direction of second vector. We get same answers from all these three equations. There is no difference. We can write the dot product in all these three forms. This equation can be used when we are given the magnitudes of both vectors. If we are not given the magnitudes of A vector and B vector, instead we are given A vector and B vector in this form: A is equal to AXI plus AYJ plus AZK and B is equal to BXI plus BYJ plus BZK. Then the dot product of these two vectors can be obtained by multiplying similar components. That is, we multiply AX with BX and AY with BY and AZ with BZ. Here I and to I is equal to I square, or we can see from the definition of dot product, I dot I is equal to magnitude of I vector into magnitude of I into cos of theta. Magnitude of I is 1, magnitude of I is 1, and I makes an angle of 0 degree with I, so cos of 0 is equal to 1, so I dot I or I square is equal to 1. Similarly, J dot J or J square is equal to 1 and K dot K or K square is equal to 1, and we get the dot product of A and B in this way.